So in this section, we're going to look at the process results from the NIST MAB peptide MAM experiment. Okay, so the processing is now complete and we can start to navigate down the different steps. So the first step is the system suitability step. So we injected 6 SST samples at the beginning and the end of the run. Okay, so when we look at the SST results, we can see one of the views is this trend view, and it shows things like mass error, retention time error, standardized intensity, and the peak width criteria over the run. Okay. You can also look directly at the data in chromatographic form. So, for example, if you pick one of the samples, we can look at the TIC and the BPI or the UV. Okay, we've got the pass-fail criteria down here, so everything's passed. So for the 7 peptides, all the criteria was met. So if anything had failed, it would appear red in this column here, so you would know immediately if for some reason an SST sample hadn't met the criteria that was specified in the method, and it would flag it up, so it would be a nice visual way of checking that. Okay, but here everything's passed, so we could be confident that the system is robust and all the data has been acquired correctly. So if you look at the ejection step now, which is the next step down, we can see here we've got a list of all the injected samples. So we've got here the blank, the SST, and down to the control. And again, you can just quickly have a look at the chromatograms, again in the different forms, and just really, you know, get to look at the data. So once you're happy with how the data looks, or you might want to skip that step completely. The next one is retention time alignment. So we chose a sample, I think it was unknown sample 2, that was going to be the retention time alignment reference. So everything will be aligned to that. So we can see here we have the control sample before and after alignment. So if we zoom in and change it to sample 3, we can see here that there's a very, very slight change before and after alignment. Okay, so the data has been retention time aligned. Okay, but it was pretty good beforehand anyway. So once you're happy with the retention time alignment, everything's looking good. The main part of the data review is looking at the monitored attributes. Okay, so there were 6 attributes in the method that we were looking at, and we get a nice visual representation of each of these CQAs, so each attribute over the batch of samples. Okay, so this sample set consisted of a control sample, which was number 1, and 3 unknowns. And we can see here that a couple, in some cases, sample 2 and 4 have exceeded the threshold, and these were the 2 stress samples. Okay, so you would kind of expect this in this analysis, but it's a nice way of actually showing you how the software flags up when something has exceeded a limit. Okay, you see here we get a different colour and we get a little warning triangle, so we know exactly when we have a value outside the acceptable range. So we can view the data in this way by attributes. So each of these histograms represents an individual attribute, for example, a pyroglue, and you can track that over the batch of samples. You can also look at the results by sample. So here we can see the control sample and how each of the 6 attributes behave in the control sample, in unknown sample 1, 2, and 3. Okay, so depending on how you want to view the data and what type of analysis you're doing, you might want to either use both or just an individual view. Also in this step, we can look at individual attributes, and we can look at spectral data. So for example, we can look at the pyroglue in unknown sample 2, so we say view injection. Okay, so it's giving us the extracted ion chromatogram and also the spectral data. Okay, and we can zoom in and look at that. And we can do that for several different things. So we look at one that's outside the range, it's flagged up. Okay, so we've got the multiply charged ions for this peptide. And again, we can look at the spectral data to see if it's in keeping with the quality we expect. So everything is kind of easily accessible and readily available to go in and check. But this kind of instant visual representation of whether things have passed and failed is a really nice way of viewing the data. So that is the review of the monitored attributes. In the next section, we're going to look at the new peak detection results.